to technical session 8B. This is planning for resiliency. So as engineers, no matter how much effort we put into doing the design, this is when everything goes wrong and you have to innovate and come up with new solutions. So got three great speakers today, or actually four great speakers, three great presentations. I'm Jody with Arcadis, and I'm also from the Georgia section. So I'll be your moderator. I'll be introducing each of the speakers, and then they'll be going through their presentation. I know most of you have been in a Zoom meeting before. We encourage you to use the chat box to ask any questions. As you guys will be muted as attendees, you're muted. So we encourage you to use the chat box. And as the speakers wrap up their presentations, we'll have some time for Q&A after each presentation, and I'll be sure to get your questions to them. So with that, we'll move into our first speaker. Our first speaker is Kimberly McDaniel from Fenstermaker. The sponsors up here. So Kimberly is the Baton Rouge operations leader for Fenstermaker. She has 16 years of experience in the engineering industry. She has her bachelor's in civil engineering from Louisiana Tech and her master's from Wayne State. Throughout her career, she's performed some numerous corridor studies, traffic impact analyses, feasibility studies, and some crash and safety work, along with a host of other pretty much everything that you could do in the transportation and traffic field. Prior to joining the consulting industry, Ms. McDaniel spent 6 years working at Louisiana DOTD in their traffic engineering management. So Kimberly, if you want to go ahead and get started.
Sure. Can you guys hear me okay?
Sounds good.
Okay, awesome. So good morning, everyone. Thanks for the opportunity to do this. Excited to share this project with you guys this morning. So we titled this presentation 10,000 Red Dots, and I'll get into why we gave it that title in a little while, but it's reminiscent of the song 10,000 Hours, if you're familiar with that song, because that kind of became our theme when we talked about this project. So I'll just kind of dive right in. So I'm sure you were familiar with Hurricane Laura that hit the Gulf Coast back in August, the end of August of last year. So about 8 months ago, it hit the southwest part of the state of Louisiana the hardest. It made landfall right at Cameron Parish, or right at Cameron, Louisiana, and Cameron Parish. Drove the eye straight through the Lake Charles area. It was a terrible hurricane. They thought it was going to come in at a Cat 5. It made landfall as a Cat 4, but I think it was 5-mile-an-hour winds, less than what would have been needed to consider it a Category 5. They had sustained winds of 150 miles an hour. Those were sustained for longer than 1 minute at a time. Most of the damage resulted from wind, not from flooding. Surprisingly, I think they were prepared for some incredible storm surge, prepared for some flooding. And while some of it did occur, they had a 10-foot storm surge. The flooding was not nearly as catastrophic as wind damage. It actually tied with a hurricane from 1856 as the strongest to ever hit Louisiana. So I think that's unusual because in Louisiana, I think we're all kind of scarred by Katrina. And Katrina becomes our sort of like pinpoint, at least for those of us of this generation. Katrina is the one that kind of sticks out in our mind, but this storm was much stronger than Katrina. And of course, hit a completely different part of the state. I'm here in Baton Rouge. We really we got some strong rain, we got some strong winds, but we didn't nearly get the force that the southwestern part of the state experienced. There were 42 deaths attributed to the storm. And as of right now, the estimate of damages throughout the state and into Southeast Texas is around $19.1 billion. So pretty catastrophic, pretty damaging. So we sat here in Baton Rouge, watching the damage, watching the news, watching this happen. Really not much that we could do. As the hurricane moved through and we started to, or a local official started to assess damages, the entire parish of Calcasieu Parish, Cameron Parish, you can see on the map, everything that's in that really dark red they were 100% without power. So a big majority of the state did not have power at all. And when you lose power, you lose everything. You lose your signals, you lose your sewer and water systems, all sorts of things go offline. So the damages were just really, really bad. And a lot of it was attributed to the wind, to flying debris, things like that. So they ordered an evacuation prior to the hurricane. People listened, people got out of those areas. We have a strong relationship at Fenstermaker with Calcasieu Parish. We do a lot of work with the parish. And on that following Monday, so the hurricane passed through a Wednesday night or into Thursday morning. They started assessing damages over the weekend, started to allow people on that Saturday, although there was a strict curfew in place, started to allow people to come back in and assess their personal damage, assess personal situations, but you had to leave before the curfew ended and things like that. They weren't allowing people to stay in the parish overnight unless you had special permission because of your job, your essential job. And so that's when they started to realize they had some traffic issues, not only traffic issues getting in and out of the parish, but within the parish as well. What was happening was they had all these rescue workers, they had utility companies, they had all sorts of different people coming in to help, but none of them knew where they were going. None of them knew the area, and they were starting to have crashes on the system, pretty widespread. I think on that one Sunday, they had 18 crashes during that like 6 hours of non-curfew time that they allowed people in. And what was happening was, GPS wasn't working, cell phone service wasn't working. We were talking before we started the presentation, people were using hotspots, even those weren't really working well because towers were all down. So crashes were occurring because there were no traffic control devices that really remained at intersections. So you can see a couple of these pictures right here. The one in the bottom left corner with the sign mangled and in the ditch, that was pretty commonplace. We headed down there on that Tuesday. A couple of us from Fenstermaker loaded up some supplies, loaded up, some food and some water, and drove down there and just said, look, we're going to come and we're going to try to help you sort through some of this. It was the least we could do. When we got there, we really felt the catastrophe of what had happened. It was really heavy to see that. I grew up in this part of the state. I live in Baton Rouge now, but this is just 25 miles west of my hometown. So this was home for me. And it was pretty difficult to go there and to see all of this. But about 6 or 8 of us drove over there that day, started talking to them, hearing their stories. These people are at work, but their own houses. Some of them didn't have a roof. None of them had power. None of them had water. None of them had sewer service. Many of them left their families behind in another city where they had evacuated to come back into the Calcasieu Parish area to help and to work and to do their jobs. And so we sat and we listened and we realized they were still really in pretty much a state of shock. They were having a difficult time even figuring out where to start. And so we sat down with them. We, tried to understand the problems that they had. What were their biggest concerns? One of their biggest concerns was crashes. And so, we said, okay, but your signals aren't working. Have you put stop signs up? And they hadn't. So said, look, do you have some stop signs? Let's load them up. We loaded them up into a truck and we rode around with them. We helped them put stop signs up at those intersections and just tried to kind of do what we could, just, kind of boots on the ground. What can we do to help you? And then we sat down with them after we did that and really just kind of started to sort through their problems and help them figure out to start thinking about a path to recovery. What do you need to do to move on from here if this is a big concern of yours? So we worked with them, said, this is what you have, what information do you have available? It was pretty limited, but they knew they needed to restore traffic control on their parish roadway system. So they put together an emergency RFQ. It had a really short turnaround time of, I think, maybe 5 or 7 days. We submitted along with several other firms, and ultimately our proposed assessment and repair plan was the one that they selected. So we knew immediately it was time to get to work and we needed to do it really quickly. So we turned around that plan. I mean, Diane's on the line here. I think some of you may know Diane Hammond. She works with us. I think we didn't sleep for a week trying to put this plan together and figure out how to get out there and help them. So the parish already had an existing cartograph database of most of their sign locations. So that gave us a starting point to say, okay, we kind of have an idea of what should be out there. They had about 14,000 signs on their system that we needed to locate, assess, maybe repair or replace. We didn't know yet. Crashes were still occurring on a pretty regular basis, so they were pretty stressed about getting the fix in as quickly as possible. And like I said earlier, most of the parish employees were faced with their own problems at home, so we basically just kind of took this problem from them and owned it. That residents were still displaced, there was still no power, no cell service, water and sewer was very limited, even gasoline, you had to fill up your tank about 30 to 40 miles before you got into that area because you were not going to get gas when you got there. So we brought, every time we went over there, we brought in food, we brought water, we brought any supplies that we could help with because they were in such short supply. So we had to set up some sort of data management and tracking system. We were assessing signs and we were assessing signals. So any traffic control device on their system. The big question was, how do we do this for 14,000 signs, 3 signals spread across over 1,000 square miles of the parish? And that was a huge undertaking. So we sat down with a couple of our engineers and just really started brainstorming what's the best way to tackle this. That's a lot of data to manage and to manage in a very quick fashion in an area that doesn't have much power, doesn't have much cell service. You're encountering all sorts of different things when you get out there. So for every sign, we needed to know where it was located, what the sign type was and the legend on the sign. We needed to know the post type and condition. We needed to know the anchor condition. And really, was the sign even there? In a lot of cases, we got to a place that should have had a sign and there was nothing to be found. And then we found signs that should have been in a completely different location that the wind had just picked up and basically relocated to somewhere else. And then one of the things we had to assess was it really hurricane damage? Some of the signs needed to be replaced, but one of the funny things that we ran into was there were a lot of signs with bullet holes in them. I don't think the hurricane shot the sign up. So we had to make sure that we were delineating hurricane damage from other damage on those repairs and replacement as well. And then for the signals, we needed to assess the equipment condition. We needed to know what the cabinet looked like. Was it still in good shape? And frankly, we needed a safety evaluation because before power was going to be restored, we needed to make sure that it was going to be safe to restore that power. We brought in Jeff Smith with Temple to help us with that part of it. Jeff was great. He came in and helped us to assess all of those signals on a couple of different occasions. And just, looking in the cabinet and checking everything from the wiring to the equipment to setting up some temporary power on it to see what would happen when we did restore power. And so that we can start a path forward on repairing those as well. So what we did and what we needed to do is we needed to get people on the ground as quickly as possible to start doing these assessments. And we needed a way to track all of this information and also to store photographs, because for FEMA documentation, we needed photographs of all of the damage so that we could really document well what we saw, what was taking place, and why we repaired the things that we repaired. So one of our engineers developed a mobile cell phone based application to do that. And I'll show some examples of that in just a few minutes. So we set up a priority system because tackling 14,000 signs at one time was huge. We needed to break it into pieces. So we set up a priority 1 and a priority 2 system, and then subdivided priority 1 into an A and a B so that we could get to the locations, assess and repair the locations that were most critical first. So what we did was priority 1 included all of the stop, yield, and warning signs on the parish's master transportation plan. And so that included everything on major, minor, and arterial collectors. So priority, and so we tackled those first. We did the inspection and assessment on those first. Priority B was the rest of the warning signs throughout the parish. And then priority 2 is where we got into the remaining stop and yield signs on local streets. There are a lot of, it's a relatively rural parish when you get outside of the city of Lake Charles. And so there were a lot of signs that were within small subdivisions and neighborhoods. And we didn't feel like those were the priority because, you know, when you're leaving a neighborhood, you know to stop and wait before you enter the main highway. And so that's not where the critical locations were. So we put those in the last priority bucket. So we developed an app, like I mentioned. This is completely attributable to one of our younger engineers. He amazed me, developed it overnight, called me the next day and said, hey, I think I have a solution. And we had to do some tweaking to it, but it was absolutely perfect. So it was accessible through any smartphone device. So we had people that use iPads, we had people that use Samsung devices, Google devices, iPhones, they all worked for it. You could even use the laptop if you needed to. It was GPS related. So when the inspector arrived at location, he could upload photos, put in the information, answer the questions, and it all located him from a GPS standpoint. So you knew exactly where that sign was located. So we collected information that included the lat long or the GPS location. And we had to, you know, we were working with a lot of people who are not traffic professionals. We were working with people who are construction inspectors, but we were putting them to work on this project because we needed manpower at that point. We used some survey employees, we used some construction field employees. So we had to make the app work such that it asked very specific questions to collect the information we needed. We did some training on it with them as well to make sure that we were getting the information that was necessary for us to make decisions about what repairs needed to take place. So we asked questions as simple as, are you at an intersection? Because if you logged a stop sign and it wasn't at an intersection, then we knew that would raise a red flag for us to do some further review. We needed to know the sign designation. What was on the sign? Did it say stop? Did it say a speed limit? We need to know the condition. Was it good? Was it bad? We also wanted to make sure that it wasn't bent. It still had reflectivity, all of that. As well as post condition, anchor condition, any plaques or supplemental signs that were on the same post. Did it have a street name sign? Any other comments? And then they uploaded photographs along with that. So once they did the survey in the field, once they did that inspection and it was submitted, we could access it from the office immediately in real time. So we had a crew of people in the office doing reviews right alongside the crew of people in the field that were actually doing the inspection. So we had people working on this from Lake Charles to New Orleans for several weeks at a time. So once the individual surveys in the field for each sign were done, they uploaded to what we called our dashboard. And this is just a screenshot from one point in time on that dashboard. So you'll see here, there's several different colors of dots and routes on there. This used an ArcGIS database system that allowed us to know how many signs had been assessed, how many signs had been reviewed in the office, how many were left to go, and each different color indicated a different stage for that sign or a different phase in the process. So we were able to give the links to this dashboard to the parish so that at any point in time, they had real-time answers on what was being assessed and how much progress was being made. It was great for them because they were giving daily updates and press conferences and Facebook Live events so that they could inform people who, because they still were under a don't come home order, they're still under an evacuation order. And so people were dying for information. And so this was able to give them some very real-time information to share with residents that were not back home yet, that were displaced still, and they could understand what progress was being made. And it was great for the parish officials to be able to say, look, here's some real information on some progress that we're making. And so, but it also helped all of us know, were we making progress and what did that look like? It was very visual. So that was really, really helpful. So we did field assessments like I mentioned, there were nearly 14,000 signs. Most of those in priority 1 and 2, or priority 1A and B. In 15 days, we had a sub-consultant, Meyer Engineers, which is a local engineering firm in the Sulphur area, so in Calcasieu Parish. And then we also worked with the parish forces. So we had as many consultant people on the ground as we did parish employees on the ground doing this. And because it was an app and because it was just used from any phone, we were able to share it with everyone. In 15 days, with that many people working, we worked in 2-man crews. We didn't want anyone out there alone. There were just way too many hazards out there for anyone to be trying to do this independently. So we worked in 2-man crews. Most days we had 10 to 15 2-man crews out on the job. So in a course of 15 days, we assessed almost 10,000 signs. We were averaging about 614 signs per day that we were assessing the location, the condition, uploading photographs, so that we could make some decisions in the office. So our in-office reviews, this is where the 10,000 red dots came in. We had, I think at one point, up to 8 or 9 people in the office who spent all day clicking red dots on the computer screen to make some assessment decisions. So in the office, we used that dashboard that I showed earlier. Each one of those dots, once you clicked on the dot, you would get these reports. So the upper right-hand page of the screen right now was the reported information that the inspector in the field uploaded, as well as the photograph that they uploaded. So we had engineers in the office who were going through and double checking, you know, if they clicked on the right sign legend or the right sign type, and just making decisions like, you know, reviewing and confirming the decisions made in the field about what needed to be replaced, what needed to be repaired. Could we keep the post? Could we keep part of the sign or not? So then the next thing was we had to get a contractor on board, and we had to do it pretty quickly. So within just a couple of weeks of starting the assessments, we also advertised for a contractor. We really had no idea on quantities. It was completely estimated. We really had to think about it as if it was almost a design build type project, because we wanted the contractor on board and ready to start working well before we were going to be done with all of the assessments. Traffic Solutions was the low bidder in the project. We did have a pre-bid meeting to explain the uncertainty given the quantities and the work. We also explained the working conditions because they were obviously less than ideal. The area still had very little power restored at that point. All direction given to the contractor was provided through the same dashboard and app. Another module of the app was created so that the contractor could record their work through the app. We never developed, any sort of printed plans or anything like that. Everything worked through that app and through that dashboard. So it progressed very much like a design build type project. We were just a couple of days ahead of the contractor as he was going out there and getting the repairs done. And the repairs from the contractor followed the same priority system as our assessments so that we could get the most critical signs up first. And then Hurricane Delta hit. So literally 2 days after we had finished all of our assessments in the field, Hurricane Delta made landfall in the exact same area. This storm brought a lot less winds, but a lot more water. So the damages were a little bit different, but then we were faced with the question of how do we track Delta damage that wasn't Laura damage, because when you're submitting for FEMA reimbursements and things like that, you have to segregate the two as best you can. So we had to go back into the database and create yet another module of the app so that luckily we had finished the Laura assessments. So when they got to a sign that was damaged that maybe hadn't been damaged on the Laura assessments, we knew the damage could be attributable to Hurricane Delta. So not only had this area been hit once, but it was a 1-2 punch. They got hit again, and now we're doing essentially simultaneous double assessments. Once the contractor got on the ground to start doing his work, we needed an inspector to follow those contractors around to make sure that the signs were installed correctly in the right place, and also that quantities were being tracked. So Again, another module of the app was created so that we could document the repairs and track and verify quantities, take photographs and things like that. So documentation was just a huge, huge part of this whole project. And then at the same time, we had the inspectors noting any damage that they noticed when they got to those locations that had not been previously reported so that we could attribute them to Hurricane Delta damage, segregate that into a separate repair and replacement project. And then we started noticing that, there was still some damages out there that maybe hadn't been noticed yet. So we set up yet another module within the app that allowed any employee, anybody who worked for the parish, who worked for the contractor, who worked for us, to report other damages that they were noticing when they were out in the field. We call this our punch list of things that needed to be taken care of. And the parish actually sent their crews out to take care of these so that we could keep it separate from the other contracts. So far to date, there were 26 reports of other damages that needed to be corrected. And then there were the signal repairs. So as they started to get close to getting power restored, we started looking at how to repair those signals. I mentioned earlier that Jeff Smith came in as an expert to assist us with the damages and the assessments to the signal systems, the cabinets, the controllers, the wiring, the signs, everything. We had one signal that had some pretty significant foundation damage on one of the mast arm foundations. So that had to be corrected. The contractor EP Bro was selected to come in and do the signal repairs. So we worked directly alongside with them. They had actually done the original installation for all 3 signals. So they had the as-built plans available. So we were able to kind of use those as a guide for what needed to be out there and got those repairs done as well. Luckily, only 3 signals on the parish system. The rest were either on state or city systems in that area. So in the course of construction, they inspected another, to date, I think 6,206 signs have been repaired. There's been 80 working days, and they averaged a repair of 78 signs per day over the course of the project. That's as of this past Wednesday. The average number of inspectors per day was 2 to 3. One inspector was assigned to each 2-man sign crew. And that was 6 inspectors out there at most at any one time with 6 different sign crews. So work continues. We're almost done. We're seeing the light at the end of the tunnel now for the replacement. So we began in August 26th when Hurricane Laura made landfall. As of December 22nd, even with Delta coming in and kind of putting a kink in the system, as of December 22nd, all priority 1 signs had been repaired and replaced. So the critical signs on the parish's system were all repaired before the end of the year. So we were really proud of that milestone. Here we are in April. All priority 2 signs we believe will be repaired or replaced by the end of this month. We have approximately 600 signs that remain. We did end up entering into a separate, or the parish entered into a separate contract with a signing contractor who ended up being the same contractor to do the Delta damages. So as soon as the Laura damages are completed into this month, an NTP will be issued to take care of the additional Delta damages. They're doing the repairs overall at a completed rate of 35 signs per day per crew. So that's a pretty significant number of signs that are being replaced. We're averaging about 4 crews per day at about 140 signs being repaired and replaced per day. So that's kind of where we are with that. I don't know, Jody, if you want to take any questions at this point or hold until the end.
We do have a couple of questions. I think we've got time for maybe 1 or 2 questions. So the ArcGIS, the map that you showed, was that public facing or was that really for your internal teams?
It could have been public facing. I don't believe that the parish ever posted the link to that map publicly. They shared it internally with the parish and the local cities and officials in that area. I do know that some screenshots from it were shared on social media just to provide updates to the residents, but it could have been public facing if they had wanted it to be, but they kept it within the parish system.
Okay. And then also, did you guys contract out the inspectors or were those people from your team?
So we have a force of about a little over a dozen contractor or construction inspectors within Fenstermaker. We also use some of our survey field crews. We actually had several active survey and construction projects in the area that was hit by Hurricane Laura and then subsequently Delta. Those projects ended up being put on hold as a result of the hurricanes. And so we were able to take those employees and sort of convert them into signing inspectors. In addition to that, we worked with, I mentioned Meyer Engineers, another local firm. We had about a half dozen of their inspectors on and off, which was great because we were able to help them get their guys back into work because they had some of the same situations where their projects were on hold. So we were able to help them out a little bit and they helped us. And then some of the parish people, parish employees also did some of the inspections.
Excellent. Well, Kimberly, thank you very much. Great presentation. Interesting stuff.
Thank you.
And it's not something you can really ever plan for. You just kind of have to
react. We winged it.
So we're going to go next to our next speaker is Don Bennett. And so we're switching from one hurricane story to another. So Don is a senior transportation engineer with Davenport in Wilmington, North Carolina. So if we would have been in person, we could have all had a social event at Don's house. But unfortunately, we're virtual. So prior to joining Davenport, Don worked in North Carolina DOT and served 13 years as the city traffic engineer for the city of Wilmington. He has a Bachelor of Science from North Carolina State University. So Don, we can see your presentation there. I think we're good to go.
Okay, much like Kimberly, I'll go ahead and set the context on this. Whereas most hurricanes like to hit you and leave, and it's a 6 or 7 hour event, Hurricane Florence was pretty much a 3-day event for us. It kind of sat on top of us for about 48 hours before it moved on. Dumped a lot of rain, not much in the way of wind, but primarily the rain became the issue. About 24 hours after the hurricane hit, we lost all roads into town, which meant restoration services, joint mutual aid assistance couldn't get in. And many of our employees who worked for the city and our field crews and our police departments and our fire departments were not able to get in. So we had severe manpower shortages and no way to bring people in for support services. And that lasted for about another 2 days. And then we got one road coming in, which was US 17 from Jacksonville. One person commented that what used to be a 2-hour trip from Raleigh to Wilmington now was an all-day event. So the first thing that we ran into was, of course, with that much rain, we had some culverts that started to fail. And we had one of our streets here locally, 16th Street, which is the southbound movement of a one-way, the southbound couplet of a one-way system, had a triple box culvert under it that had scour up to about 6 feet under both outside lanes. So NCDOT elected to close that. And again, with all the rain we received, alternate routes for flooding. This was also the major response route to our local regional medical center. Now, this is the only medical trauma center in southeastern North Carolina. And what we noted is that some of the joint responders had staged inside that flood perimeter. So we were seeing ambulances from other towns, other cities, and other states. Their GPS was telling them to get to the hospital via 16th Street, which was no longer available. Fortunately, these were 3-lane roads on both. So we used a one-way, the 17th Street, we used a one-way couplet. If you'll notice, a lot of this stuff is hand sketched in. One of the things we discovered at our operations center was that our CAD license for AutoCAD resided on the server downtown, and we didn't have connectivity to that. So it was basically, we had to connect the plotter to the local computer, get via a 4G download, get some drivers, and we were able to plot out aerials, and then it was time to break out the ink pens and markers and actually come up with some plans. In this case, if you were coming down Greenfield Street, you had to turn left onto a 3-lane section, right going the wrong way on the one-way couplet, and then make a right turn to return to the traffic signal. This allowed local first responders to have approximately 15-20 minutes on the alternate route to the hospital trimmed off And again, this is the local trauma center. So execution, we had a amalgamation of a local traffic control contractor, secured traffic control to provide much of our hardware. And then we had some boards here with the city of VMS boards with the city of Wilmington. This was a pre-approved purchase order contract that we had in place. So all I had to do was call him and say, I need X number of cones and I need them here. We used the center lane on that 3-lane section as a buffer between the directions. And then as power came back up, we found out there where the traffic signals were operating on 16th and 17th streets, we had to modify some programming and modify some sequencing to make the detour run. And we had one of the things that became particularly poignant after this was people were trying to get fuel. And we had a gas station that was just south of the return route back to 16th Street, where it actually did queue up through that return route. And we worked with them to reconfigure their circulation to alleviate that. And then the Burger King that was on this is a Burger King right here. We worked with them to have their employees help us with a left in, left out pattern there, which helped the return path quite a bit. Now, end of about day 2, we're all getting a little bit draggled here. I'm focusing on doing assessment with the remaining crews that I have. And one of our traffic officers, who we have a very good working relationship, or had a very good working relationship with in the city traffic, calls me up and says, hey, I live in a neighborhood with a roundabout, and we pulled some stuff out of our DWI checkpoint trailer, and we've set up a roundabout at one of the major intersections. When you look at the observations of traffic signals, dark traffic signals, which by North Carolina statute are an always stop, on 5-lane approaches, where you have 4 or 5-lane approaches to both, or 2 to 3-lane approaches on all approach to the traffic signals, they do not work well as always stops. The first car in line takes off and everybody else just plays follow the leader. Unless there's an officer there, compliance is spotty if your main line stops at all. And if he is there, he'll be expected to direct traffic, which again, what we're looking at is we can't get resources and people into town to provide this service. So the officer is exposed to both weather and traffic. There's personal, and they're expected to provide information. Hey, where can I find bread, milk, eggs, gas? Where can I find these things that I need from the people inside that perimeter? So the officer actually used his crash his crash software to provide a design. And this is what they came up with, and that was the plan. They executed it, and they had to make some adjustments, but they mainly called us for, hey, can you get us some signs out here to tell people that this is operating as a roundabout? The good news is this reduced the officer load from approximately 12 to 16 for a 24-hour shift down to 2 or 3, and they got to sit in their car with the blue lights on. So the traffic was allowed to flow around. People weren't stopping to ask the officer questions, and he's protected from the elements and the traffic inside the car. So the cones were provided by the police department, and signs were added later by traffic engineering. And believe it or not, despite closing down 4 or 5 lanes with 10 cones over 50 feet, it actually worked relatively well. We can see that there's a truck in here. The other function of the officer in the middle of the intersection is when the truck comes through, is to reset the cones in the inner circle, in the center island. And then it's in action. We actually had the fortune that the Wrightsville Beach Ocean Rescue had a drone and happened to have a good working relationship with the city of Wilmington. So as you can see here, circulating speeds are very slow, but it's pretty much accommodating most of our design vehicles coming through here. So the lessons we learned, increase the tapers. People do not like to move over that fast in that short of a time. Even though there was a night curfew, the light towers were needed because, well, you got an officer sitting out there in a dark intersection, and even though he's got his blue lights on, it still presents a significant safety exposure for him. And we needed a trailer with a playbook and the necessary materials necessary to implement these things. Wilmington is very hurricane prone. Bonnie, Floyd, Bertha, Fran, Florence. It seems like the F storm seemed to always knock us out. And the officers also found out that with the new LED light bars, having the full lights running created glare issues for drivers who were approaching. And they found out that they could use their 4-corner blue solid on that was less distracting for the approaching drivers. So again, we have access to a plotter. At this point, we've gotten a license to AutoCAD, so we start laying things out so we can give our contractors some idea of what they're going to be putting out there. And the contractor's purpose is just to get the materials out there. I physically and personally had to go out and adjust the location of all the cones and get it set up so that it was operating the way I intended to for on the design. So the design became a starting point. So again, secured traffic control. Now you can start to see we've actually got a formal center circle. It's not exactly circular. We found out that a roundabout could be constructed with about 300 to 400 cones. A 30-foot piece of string and a can of spray paint, 8 sign stands and 8 signs. So you can see we're starting to develop some tapers here. We're moving them to the outside lane. We've got a little larger circulating circle, starting to look more like a formal roundabout. So again, Riceville Beach was kind enough to give us some aerial shots. We can see trucks with trailers with it, single units are going through, and then behind it we got a truck with a Bobcat on it. Those things worked well, but then you run into different situations. Again, you can notice what we found out is that we can get a roundabout to go in any intersection that has about 110-foot square in the middle. So the circulating roadway, we had to flare that out to accommodate the trucks and minimize the number of times that the times that the officer had to get out and reset the cones. Fortunately, because we had used that spray paint and the string, the officer always had a reference point for where to put the cone back. And the cones make for a ready truck apron. They can run over. You just got to make sure your sign stands are not inside that informal truck apron. And the entry lanes required flare because we were stretching those flares out and we were getting some approach speeds that were a little disconcerting. So then we go to version 3.0. We had to simplify the plans now. We're starting to run out of people and resources. Everybody's getting tired. And so now we start getting up. You can start to see some entry flare on the approaches. The circle's getting a little more defined. If you'll notice, this traffic signal head is actually facing the wrong direction, and there are no westbound approach indications. They're all laying over here by the cabinet, piled up on the span. So even if we had power, we could not have restored that intersection. But you can start to see the signs here on the approach. They're visible. They indicate circulating roadway and that it is under roundabout control. We got our overhead video again. As you can see, we actually have a bicyclist going in here. So yes, your portable roundabouts and temporary roundabouts can actually operate with multimodal accommodations. But we're starting to see some better circulating speeds. We're starting to see a little more capacity come out of them. So, the lessons learned, where the left turn bays start to flare out, that's where you want to start your tapers. Primarily because you don't need people starting to move over in those left turn lanes and then realizing they got to come back to the right again. Installing reverse curve on the entry. We need to break that speed. The other thing is that when people are approaching the roundabout, we actually found out we don't want them to see a clear, straight path through. At night, it was just a field of pixelated cone reflectors, but it pretty much forced oncoming traffic to slow down and evaluate what was going on. You got to break the pavement markings. We were seeing cones knocked over where people were trying to stay in the lane marking, but couldn't quite do it. So at that point, we're deciding, let's go ahead and get them completely off the lane markings and get them to following the direction they're being given by both the cones and the signs. If you have dual lanes on the outside and a right turn lane on the approach, you can, in fact, get some slip lanes in there. You just got to extend your exiting traffic a little bit, keep your merge on exit from becoming an issue. And roundabouts self-preempt. That regional medical center, this intersection was about 3/4 of a mile south of the regional medical center. What we found is that the emergency vehicles would leave the hospital and they had their lights and sirens going, and people at the roundabouts would actually stop entering except for the approach coming from the hospital. And those drivers would just start taking the roundabout and moving out of the way. The fire engines and the ambulances didn't even have to wait behind them. So watching those self-preempt was actually somewhat of a surprise. So now we get to version 4.0. Again, we're just simplifying the plans, trying to get the materials out there. We know we're going to make the adjustments when they get there. And unfortunately, at this time, Riceville Beach did not have the ability to get out there. But at the time this came in, the request was made by State Highway Patrol. This is the first location outside of Wilmington. So we worked with the North Carolina DOT Incident Response or Incident Management Center, worked through their IC command, got permission to implement outside the city of Wilmington. We incorporated all the full lanes. At this point, US 17 coming in from Porter's Neck is the only road into Wilmington. All your relief services and all your citizens returning are coming back. More cones, and we really observed the capacity limitations on a single lane roundabout. But State Highway Patrol kept 2 officers there. And with 2 officers there, they were actually able to shut off the 3 approaches for that were not US 17 southbound by just moving some cones, telling people to wait. And then the officer would get on that southbound approach and he would just wave people into the roundabout, let them go wherever they needed to go and flush out that approach. So the lessons learned from the single lane roundabout, they have a capacity, and it's about 60% based upon the very limited data we had from the overhead video. Although they do have a limited capacity, they work a lot better than 5-lane approaches to all-way stops. And if something did go wrong, it was resetting some cones, it was maybe a fender bender, no injuries. That's what we see with roundabouts in general. There were no crashes reported. We did go back and look at the collision reports at each of the locations where those had been put in, and even with the version 1.0, no collisions during that time. We found out that we had a greater capacity in the areas where people are accustomed to roundabouts. In that Porter's Neck location, there was a roundabout east that site, about 1.5 miles. The locals were used to using it. And Southern drivers, I will say this, bless their heart, courtesy kills capacity. We would see quite a few times where drivers in the circulating roadway would stop to wave somebody in. And be careful when you're having to use a cell phone to document your plans and get them on the page. Make sure you keep your foot out of the picture. Takes a team when this happens, and a lot of these places and relationships were in place prior to the event. We had our police department, Wilmington Traffic Engineering, Streets and Traffic Division of our Public Services Group. We had a contractor and the DOT's contractor for traffic control devices, the Incident Command in Division 3, and then of course Kittleson and Associates coming in, local guy, Bastian Schroeder, really good with roundabout modeling and research, and he was able to dissect some of that video and come up with some of what we thought were reasonable capacity restraints. And that would be the end if we have questions.
Thanks, Don. A great presentation. If there's anyone that has any questions, you can be sure to put those in the Q&A box or the chat box, either one. One that I questioned on, maybe something you didn't quite cover, going forward, are you guys looking at being a little more aggressive about implementing, okay, we've got these 10 intersections that are always an issue, and for each intersection we need X number of cones, and here's the the ready, almost that playbook that's ready? Is that something that you guys are doing?
Well, I retired from the city of Wilmington in June of 2020, and my predecessor, that we were still working on coming up with typical designs so that we had a typical to deployed intersections. There were certain intersections we identified, especially 55-mile-an-hour approaches with more than 3 or more than 2 through lanes. We had decided, if we've got 2 or 3 generators, we'll take the generators out there as long as we have it. We had 3 generators on site. We had 2 intersections where we established generator power on the location. It was safe to start up, and 1 officer was stationed in there as much as anything, just to make sure the generator didn't grow legs and head off, but also he was monitoring the fuel gauge on top. He would radio back to central, hey, I'm starting to get low on fuel. Traffic engineering would deploy an employee out there to, in conjunction with the officers, to establish temporary officer control of the intersection, shut the generator down, allow it to cool, safely refuel it, and then get it started back up again. And then the officers could move on. So it was, the purpose of the officer was security at the location, and also to make sure that that generator had fuel. The other thing we found out is we had 2,300, 2,400 watt generators. Earlier than this, all of our indications are at LEDs. So we were drawing 0.5 amps during the worst yellow clearance. Basically, you're looking at using a 2,500 watt, 3,000 watt generator to power something that uses less than a hairdryer. But that was the approach we took. So again, the playbook is being developed, the typicals are being developed, so that you can have persons to reasonably get it installed without having one person solely responsible for it.
Great. Well, Don, thank you very much. Very interesting presentation. Great information, and great to see how you guys were able to react. And I love the ingenuity of the police officer. Well, I got some cones in my car. We'll just put those out and see what happens. So great information. Thank you.
Thank you.
So up next, we've got Stephen Fowler and Andrew Smith from RS&H. So if I think Stephen's going to be sharing. Excellent. So we're going from hurricanes to still close to the coast. We're going to bridges now. So Stephen is a senior structural engineer with RS&H with a focus on bridges and transportation related structures. He holds a bachelor's of science in civil engineering from the University of Florida, where he has previously served as a TA and a tutor for courses in numerical methods, MathCAD, and structural analysis. He's a leader in the state of Florida in risk management and design for vessel collision impacts. And Andrew Smith is a PE and structural engineer, and is a senior bridge engineer and leads the RS&H Charleston office. He has over 20 years of experience, including a wide range of bridge and transportation projects for all mode of transportation, from vehicles to pedestrians and even rail. And this covers kind of standard as well as complex bridge projects. He's worked on projects across the U.S. from the planning level through design and construction, and even in-service inspection. Through his career, Andrew has been involved in the design of bridges delivered through traditional and design build projects, including emergency replacements and filling key roles in the technical design and the project management. He has a bachelor's of science from the Citadel and a master's in civil engineering from Florida State. So I'm not sure if there'll be any Gators and Seminole competition or a little hazing going on here, but welcome Stephen and Andrew.
Thanks, Jody.
Thank you.
All right. Morning, everyone. As Jody said, I'm Andrew Smith, and Steve Fowler and I, we're going to give a rundown on the Matthews Bridge emergency replacements down in Jacksonville, Florida. We'll start off with a video that we put together that kind of gives a good highlight of all that happens, about 5 minutes, but it really explains a lot what's going on. Then Steve and I will talk through a little more in depth on what each aspect was.
We was just standing there watching the ship pass by. And one guy said that he thought that rigging shifts was too high. The outboard side, the port side hit the bridge. All kind of structural steel started falling up there. It took 5 seconds, 1, 2, 3, and it was right through the bridge. It happened in a blink of an eye. And we was waiting for the bridge to fall, because there was cars passing by. You could see cars passing by.
So as I dropped my phone back in my pocket, I saw it start to hit, so then I pulled my phone back out and called 911.
Immediately following the incident, a lot of 911 calls came in from concerned people. It was a 51,000 plus vessel, and it had severed one of the 2 lower cords of the truss bridge. And at that point, I'm thinking, how is the bridge still standing?
To my knowledge, a bridge has never been hit like this in the superstructure, pretty much in the center of the main span.
most people, in our industry and in construction and engineering and everything, seeing that kind of damage, immediately recognized that this was a serious problem.
We had people, our people, FDOT people and our consultants, they risked life and limb to go out on the bridge.
I remember on the way out there, they had mentioned that we should probably go 3 at a time in case, just for safety.
It was very eerie on that bridge. Who's going over the side of that bridge in this wind, in the rain?
We were scared. We didn't know what to expect. I saw what it was, that the lower cord, the tension cord was just sliced. It was just gone, disconnected.
When you see the pictures, the major cord on the bridge that's carrying the load is severed. The magnitude of the destruction to the structure, to the steel structure, is the worst I've ever seen.
It's as bad as it gets. It's one of those situations where collapse was imminent.
You can ask, well, how close to being a catastrophic event was it? It was within a few feet.
Our drive was to get the bridge open quickly, but then you also have to balance the structural integrity and the safety of the bridge.
How fast could we get the bridge back open safely and know that we had a quality job at the same time?
How are you going to do this? What's it going to take? How are you going to move the steel? How are you going to anchor it? Can the deck take the load?
There's not a textbook and not a computer program that you can open up and say, how do we repair the Matthews Bridge? When you get vertical and horizontal displacement, you have to pull that back into location. Well, the problem is, what do you anchor that to? We can't hang a hook up in the cloud.
As Will Watts told us on the bridge, to come back to the office and come up with a plan for a plan.
Some of these folks spend the whole 3 days in the office, 24/7. They just ate, sleep this project.
76 hours after the initial impact, we handed over bid documents to proposed bidders.
Essentially, at the end of the day, we set up for 24/7 operations on the bridge. We had tents and folks on site around the clock.
Problems would get resolved before we knew there were problems.
The shop drawing process went so fast that, things were changing on a daily basis, on an hourly basis.
It was seamless. Everybody was working together. Everybody was in it for the bridge.
We were able to open the bridge at 5:30 a.m., 28 days into the contract, 34 days after the initial impact. Cutting that from 40 days to 28 days is miraculous. And you run the percentages on that, and I'll take those all day long.
The reason we're able to do that is because of our excellent relationships and collaboration with our industry partners.
The fact that it took close to 200 people by hand to fix this bridge is an amazing thing.
It's the people behind the project that really dug in and got this job done. There was some tremendously amazing engineering done. There was a lot of hard work by the departments, the contractors, inspectors. Everyone worked extremely hard for this project, all to bring it together for the people of Jacksonville who will never know any of their names.
All right, so we're on the day of the impact and we're showing the location where the vessel hit and couple of the pictures that we see. And first information we've got is that they've severed the cord. So, some of the thoughts going through our head, we know the bridge has been struck. Is it slowly collapsing? Is it stable? We had video evidence showing some large trucks, 18-wheelers and school buses crossing the bridge after it was hit. So we estimated that it could handle a 5-ton load based on some of the loading that we saw. So we're 150 feet up in the air. The impact's below deck. It's not even an easy place to get to see. You can't get to it from the bottom. So we have to bring out inspectors using rope climbing gear to hang over the side and inspect the damage and start getting some information so we can figure out what's going on. So the findings from the inspection are, we know at the site of the impact, we've got the bottom cord has been severed. And the gusset plate that connects it has been damaged. Underneath, the laterals that add stability to the structure have shifted and failed. And then we've seen where the floor beams have moved also, as they were trying to redistribute some of the load through. The bottom cord is a fracture critical member, so in typical speak, that means losing that could potentially lose the structure. So we know we've got a major issue here. So on the first weekend, we had to develop a plan for the repair, and we were able to develop the plan, designs, and drawings and scopes in that first 76 hours so that we can start working towards a solution. So we've done the inspection, they've declared the emergency, and now we're trying to get all our plans pulled together so the contractor will know what they've got to do to repair the bridge. We pulled the construction package together, and they have coordination with the contractors. They had 5 that they discussed it with to get bids turned in. So now let's talk about the repair plan. 3 major items. There's a strong back in case we were to have an issue with the pins supporting the span, a temporary cord to restore the capacity of the truss, and then reinstall the permanent cord to fix the damage. So here you can kind of see a graphic showing what the repair plan is. First, we're putting in the strong back in case these pins that are shown with the black circles were to fail. We didn't see any damage, but we weren't sure, and that would drop the entire span. So that was a very important item first. Once we get that in, get some of the damaged material out of the way so that we can install the temporary, put strain gauges so we can watch what the structure is doing as we start to pull it. Then we'll install the temporary tie. These are some brackets that support the PT bars. Then we'll put the bars in and stress them, and then that restores that force in the cord member. Once that's in, then we can get in and repair some of that local damage and then reinstall the new stub. This was actually a contractor item that Steve will get into. But then we'll install the new cord member and repair the truss. Then we can remove the temporary, I keep wanting to get rid of the PT bars. Then we'll pull the PT bars out after we fix it. So. All right, so just some kind of information on how a truss works. You can see the configuration of the truss span. The sides near the piers are holding out a suspended span in the middle. The red dots showing the point of impact. Kind of turn that into a model. Here you can kind of see the forces in the elements. The size of the element kind of indicates the force in the element. Blue is in tension, red is a compression member. You can see the way this is set up that it was actually one of the most lightly loaded members on the entire bridge that actually got hit. So we're very lucky with that impact location. Okay.
All right, so now that we've been able to get out there and inspect the damage and come up with a plan, we gotta implement it, right? We actually got to do it. And so we had developed a construction package, a contract package that basically consisted of a scope of services, a construction sequence, some very basic repair plans, and then a schedule. And the schedule was not to exceed 40 days. I think there was a $50,000 bonus for every day that you finished early, and there was a $50,000 hit for any day that you finished late. 5 potential contractors were invited to come inspect the damage and bid on it. They were hand selected by FDOT because of their local experience and their prowess with this type of structure. And the winning contractor was Superior Construction, and their bid was basically 1.1 million. And as soon as we had our contractor on board, we got moving. The fabrication effort started immediately. That evening, the fabricator was actually based down in Tampa, which is a few hours away, and they worked around the clock. So their team was actually working in 3 separate shifts, and we were as well. We were doing concurrent shop drawing reviews and plan revisions. So as they came up with ideas of how to save money, or wanted to ask questions about, hey, we've got this thing lying around in the yard, can we use this instead so we don't have to order something? We were there on the phone with them sometimes 2, 3 o'clock in the morning saying, yes, you can do this, or no, you can't do that, but how about something else? So once the strong back has been constructed, they ship it on out to the site. And so one of the things that we did for the design of the strong back system is we didn't want to put anything that was too prescriptive on there, because we wanted to make sure that the fabricator and the contractor had enough flexibility to choose whatever they could that just met our criteria. So really we gave them very, very basic details, and the major criteria was a weight limit of 5 tons, and then just a minimum section modulus that they had to meet. And so they were able to go and find what was in their yard that was readily available and tailor it to the site. One of the first hurdles, I guess, that the contractor had to solve was you have all of these huge heavy objects, right, that you got to try and maneuver up here, but you can't put any cranes on the bridge because it's damaged. The existing cord, the temporary repairs, the permanent member, I mean, these things weigh many tons. And so their innovative solution was actually to rig up the entire bridge with a system of pulleys and cables and winches. So anytime they needed to move heavy objects around, they could just pick their winch position and their pulleys and drag it along. You can't really see it, in this picture. You can see all the cables and the pulleys and stuff, but that strong back, as it's being installed, is actually sitting on rollers, so they can pull it and roll it into place. It's pretty cool to watch. So once we have our suspenders on and we're not afraid of progressive collapse anymore, we got to have access to the bottom of the bridge, right? And so again, we did not. We were very loose with the requirements of the scaffolding system. All we said was that it had to be ultra lightweight. Total had to be less than 5 tons, and we gave them certain restrictions on where they could actually hang and anchor the system from in order to make sure that there weren't conflicts with the actual repair procedures. And so it was a custom design. It was built specifically for this project. And one of the cool things is that in order to hang it from the system, they used anchors in the deck and also these sky climbing rolling roof rigs. And if you're not familiar with those, quite often on large buildings, they're used to hang the window washer. And they kind of move around on top of the buildings and hang the window washers. So they actually got some of these from some local commercial buildings and used them on this project. So once we've got access, now the real work begins, right? We needed to restore the truss geometry. Basically, the temporary cord installation was there so that once we get this installed quickly, that's our big first sigh of relief, right? Because that means that we've established the natural load path for this structure. We're no longer really afraid of it collapsing. But like everything with this project, nothing comes easy. There were a lot of constraints, particularly geometry, that we had to deal with. The PT bars themselves were 66 feet long, but you can't handle that. So they were actually spliced into three segments, and each segment weighed about 300 pounds. It took 3 to 4 people to manipulate. You can see in the upper right picture, we had floor beam webs that were in the way, so we had to actually cut holes in them. You couldn't cut huge holes in them, or else they wouldn't have capacity anymore whenever you actually open the structure up. But the holes had to be very specific in their size, because when we went to go pull the geometry of the structure back, we knew that those bars were going to move about 4 inches vertically and 2 inches laterally, because that's what we had determined the bridge had actually moved out of plane when this cord was severed. There was also the whole mangled mess that had to be heat straightened. There's scaffolding, hanging around in there, and there's all sorts of other members. So once we get all the bars in, it was a cold, rainy evening whenever we went to go stress the bars. In the top left, you can see one of the jacks being lowered down into place. And there was a whole lot of monitoring data that happened that night. There were a bunch of strain gauges that were installed that we were monitoring in real time. Obviously, we were monitoring the jack loads or the bar loads in real time. And we were actually also monitoring survey targets in real time. So as these bars were being stressed and the bridge was being slowly pulled back into place, we could see it in real time through the constant survey updates. Talking about survey, a lot of people probably like, well, how are you surveying this in real time? Well, we were using a 3D laser scanner and a whole bunch of top of deck targets that were set up. They were strategically placed so that they could give us data in real time at any increment that we wanted. Here's kind of a snapshot, I guess, of the before and after of the survey. So what this is it's a loose representation of what the profile of the bridge should have been in a curve. The green line, you can see this is what the survey looked like right after impact, but before we restored the geometry. And in the upper right, there's a very clear dip. This should have been a symmetrical curve if the bridge was built correctly, and we believe it was. And so that dip coincides with the exact point of impact. The white curve is actually what the survey of the profile of the bridge was after the geometry was restored. The horizontal correction was at about 3.5 inches, and we also moved it vertically about 2.5 inches. And you can see the white, how it's pretty symmetric. So we feel that we got it back to its original geometry within about 1/4 of an inch, which is amazing. So once we get the temporary ties in, we've got the geometry pulled back together, so we think it's in the right spot. Well, now we gotta say, what do we do with this giant mangled mess? Well, heat straightening. This stuff is actually very uncommon, and it's really more of an art form than a science. There's 2 guys, I believe they're based out of Michigan, that travel around the world. They're world renowned for their ability to take these gnarly messes and put them back to their original shape. You can kind of see here, the left pictures are the before pictures, and the right is what these guys finished with. And they actually restored these members to within about 1/8 of an inch or so of their original geometry, which is amazing considering all they had was blow torches and some pneumatic presses. They did it by eye. So a crazy little nuance of this project is that down here in Jacksonville, the Florida-Georgia game is actually a really big deal. Anybody that's a football fan probably knows that. And with a mid-October date, we were about 2 weeks out from the Florida-Georgia game. So the political pressure was on, and somebody asked if we could potentially open this bridge back up to traffic before the permanent repairs were in place. Only the temporary repairs were. So he said, well, the only way to find out is to test it. And so they took the 2 interns, put them in flatbed trucks in the bottom right, loaded them up with concrete blocks and said, all right, interns, go drive across the bridge. If it falls down, oh well. Luckily for them, it held. So after all those shenanigans, the contractor needs to start installing the actual permanent repairs. Now, one thing that they actually pointed out to us pretty early on was you have this massive member that you're trying to fit into a very tight space that's not quite right because it's been heat straightened. And so they understood that trying to maneuver this huge member was going to be difficult. And so they suggested that we use a small stubby member in order to help them maneuver this thing into the gusset area and then splice the remaining portion of the permanent member onto that. So we called it a stub beam. But this was all constructability, and they'd still be out there today trying to put this in place if that stub beam wasn't there. Here you can just kind of see the sequence of events. The left is the starting mangled node with all the gussets. The middle is after the heat straightening and the stub beam has been installed. You can see somebody in there. Those things are about 4 feet deep and about 2.5 feet wide. And then on the far right, you can see the remaining portion of the permanent member has been installed. It's been painted. You can also see the PT bars are still there from the temporary fix. Here's just a couple more pictures. They actually couldn't even install the rest of the main member in one go because it weighed too much. We still had a weight limit on what they could bring out there. And so they brought in bottom and two sides as one piece, and then came back later and put the top portion on, which is why the top is missing on the left picture. You can see it on the right, not painted. So some people ask, well, you straighten these gussets, but did you strengthen them? And the answer is yes. Nobody wanted to rely on anything that had been damaged for its strength. And so, we were not smart enough to come up with this idea ourselves. We called about 25 different DOTs asking if anyone had ever seen something like this. No one had, but Ohio DOT, ODOT, had, however, developed a very unique way to strengthen gusset plates. And what it involved is taking every single rivet out one at a time and replacing it with an extra long bolt. Once the whole thing is bolts, which you can see in this upper left corner, once it's all bolts, you come in and you put a fill plate. We call it a Swiss cheese plate, so it looks like a slice of Swiss cheese, to get over those nuts. And then you come and you put the new gusset plate on top of that, and then put the remaining nuts on. So it's pretty cool. One of the challenges, though, is if you're going to do this, you got to know exactly where those bolts are, because they can be at any type of different angle coming out of there. The as-built aren't reliable. So we borrowed this $250,000 3D scanner and hung it about 10 feet out over the side of the bridge in order to 3D scan this. And it actually sent that data directly to the manufacturer in CAD, and they were able to fabricate it straight from this. Here's just a couple of pictures of the installation. The top left is the Swiss cheese plate. The bottom left, I believe, is the actual gusset plate. And then the picture on the right shows you just how tight of an area they were working with. So you can see most of the rivets have been replaced with bolts by now. And you can kind of tell how close that PT bar is to those bolts. And they have to try to fit these plates in that little gap and then get them over the bolts. So once everything's been strengthened, we got to test it again. So they called back the interns, loaded up the flatbed trucks, and had them drive back over the bridge. This is a picture of the team that was there that morning whenever they were doing the load testing. This was basically the final thing that needed buy-off and before it could be opened, but it hadn't been painted yet. They were going to open the bridge up, but still take time to paint it afterwards. And the very next morning, without any fanfare, they opened the bridge to traffic. All they did was they removed the barricades and put up on one of these DMS signs that it's now open, and traffic just started using it like normal. It was very surreal that morning. So one question we get in every presentation is, what if? Everyone wants to know, what if the structure had been impacted in a different spot? I can tell you from our experience, where it hit, everyone thought it should have collapsed. So the structure had a lot of additional redundancy that trusses don't typically have. But what we can tell you is the spot where it hit had the least amount of force of any place of a main member on the entire structure. If you were to look 30 feet to the left of the point of impact, the force in that exact same member is about 50% higher. If you were to go about 10 feet to the right, it's over 3 times higher. And so, though we can't say for sure what would have happened if the ship had impacted in another location, we're all pretty sure that if it had hit 30 feet one direction or the other, it is a much higher likelihood that the structure couldn't have survived. And then this picture right here is actually my favorite picture of the whole slideshow. It was mentioned in the video, but really this couldn't have happened without teamwork, without every partner playing their role and being selfless and willing to do whatever it took to get this project done. This is the logo of all of the companies and agencies that were involved. There were over 200 members, people that were involved in construction. But whenever you include the design team and the inspection team, at the end of the day, there were just over 400 individuals that were involved in this repair. And with that, I guess we can open it up to questions.
Great, thanks, guys. A couple of questions. One, Kevin wanted to know, did Florida DOT get reimbursed by the shipping company? So that was having all those individuals working to, do this emergency repair was not a cheap repair. So
Steve, you want to cover that or?
Yeah, so interesting enough, the shipping company that was transporting the ship actually didn't do anything wrong. They were found to have not made any errors in what they had done. The ship that they were transporting was a Navy vessel, and come to find out that Navy vessel was 5 feet taller than what it was listed at in the plans that they provided to the shipping firm. I am not actually privy to the information. Basically, FDOT is an agency that cannot be sued. The Navy is an agency that cannot be sued. And then there's the U.S. Coast Guard, which approves these types of shipping patterns. They're an agency which cannot be sued. I know that the final price tag out the door of the repairs came out to around $4.5 million. I know that there was a lot of discussions about who should pay for it, but I do not know who actually wound up with the bill.
Okay. The second question, and I think you covered a little bit of this, but so the bridge was open to traffic with the temporary repairs for the football game, for the Florida-Georgia game, and then did it closed after that again, or?
So not quite. There was a lot of political pressure because we were approaching the game to know if it could be opened. But what wound up happening is, so we tested it, and then we told them, technically yes, but as engineers, we're going to tell you no. And what wound up happening is we opened it up a few days early, and it wound up being just a couple days before the football game. So no traffic was on there during the temporary repairs. They were able to complete it. I think it was 13 days ahead of schedule.
Right.
So
I'll make a last call for any other questions for Andrew or Stephen, or really any of our presenters.
Quick question here. Maritime environment. What measures were taken to address long-term corrosion issues?
So you're talking about for the steel structure, or?
Yeah, long-term corrosion issues for the replacement and all the patching materials.
Yeah, so all steel members that were damaged were replaced. And so it's a steel structure. Any portions that were concrete that were damaged were also removed. The truss is 150 feet in the air, and so it actually doesn't see a whole lot of chloride spray that high up. And so this type of structure, its standard coating, its standard painting is corrosion resistant, and it gets painted, I believe, once every 4 years or so, and it's inspected every year. So everything, all of the new stuff basically was painted. Anything that was damaged was painted and replaced in kind, but nothing additional beyond what it was standard for the rest of the structure.
Okay. Well, thanks to all of our presenters today. Great presentations, really interesting stuff. And I've definitely learned a lot, and it's all fun stuff because it's what we see and hear about in the news. So thank you for all those that have attended. The awards and traffic bowl final rounds will be coming up at 11:15, from 11:15 to 1:45. So check your email from yesterday evening for the links to those, and hope everybody has a great rest of the day. Thank you.